Sengupta has already left an imprint on these young minds, so that they were so excited, and I think class 12 and 11, I think they are in full attendance. Yes? So almost we have a full attendance, sir. So here we have class 9, 10, 11 and 12 present. 11 and 12 had this opportunity to meet him, to interact with him last time, but 9 and 10 is here for the first time for Professor Soumitra Sengupta, a senior physicist, Dean of Academics from Indian Association for Cultivation of Science, Kolkata. And I won't take much of his time to introduce you, but I would just say, right from 8 o'clock interacting with him, I myself, I think Gordhan sir was also with me for some time, we have been enriched, and all the teachers here are also of the opinion, it's not only for you my dear students, but it is also for us, that we need also some kind of enlightenment, some kind of enrichment. And he's a musician also, he's a pianist, and just before coming here, we were just inquiring that how he manages with such great responsibility, with such with research work, collaborating with different universities. He visits school so that which he believes that science education should start from this school is the grooming ground for these minds. So how does he manage? He says the thing that you love, you can balance it. Like wonderfully explained that when he sits on the piano, the entire day strain just goes out from his body. It just moves away. So I don't know, interacting with him for this past 1 hour, 1.5 hours was something different, which I would like to have it repeatedly going on in my life to enrich myself. Same for you must be. But I think I just would like to welcome once more Professor Soumitra Sengupta here to just be with us and enlighten us with your wisdom here. And as Professor Sengupta has given us an invitation to take you all, my dear students, to you all to his institute to show the different other facets of this research field. So sir, please, I would welcome you here. Thank you, sir, for sparing your valuable time.
Good morning, everyone. It is absolutely wonderful for me to be here in this beautiful auditorium, and most importantly, in front of such very, very bright young faces. And I thank the principal of the school for a very kind introduction about me. And the only thing that probably I would like to repeat in front of you, that in your life, just go and try to do something which you love to do. That's the only thing that I can tell you. And rest will follow. Don't think about the consequence, don't think about the destiny, but enjoy the path. Whatever comes, just take it. So, my journey to science is something like this, which I started from my childhood. And at every stage, I only realized that, the meaning, the real meaning of the statement that more you know that you will more know that how little you know. So actually the entire knowledge, the entire structure of knowledge is so huge, it is very difficult for us to comprehend the whole thing. But only thing that we can do, that we can do our part and we can share among ourselves. And I have come here because I have an interest, of course. I have my own interest that I want to see many of you in the field of physics in coming years. And I'm pretty sure that you will do that, and then I will feel that my coming here is successful in some sense. So last time when I came here, I had such a beautiful experience of encountering such lovely questions that I told everybody that this is a school which is not only being governed by some wonderful teacher and possibly a great supervisor at the top, your principal, and some very, very bright students of our state. So I have a very, very high hope about you, and I went back last time with a great hope that this school is going to produce some of the finest citizens of this country. So that time I had some time constraint and I had to go back, but this time I promise that I have no time constraint and you can ask me as many questions as you want, and in fact you can ask me questions on anything you want, even that may not be in the context of today's lecture. You can ask me something else if you want in science, of course. And if I know the answer, I will try to answer it. So as you can see, the title of the talk is In the Wonderland of Elementary Particles, the Amazing Story of Higgs Boson. The story will unveil as we go, but one thing I should tell you that about 3 years back, in the month of July, we were all sitting in front of our computer screen where our institute got connected to CERN, Switzerland, Geneva, when they were just declaring the result of their search for Higgs boson. And it is not only our institute, in fact the whole world was looking at the screen to hear their announcement. And if their announcement was something negative, then probably that would have been the greatest blow to all of us. So when they announced that the Higgs boson has been discovered, you have no idea the amount of ecstasy and euphoria over the entire scientific community. My job here is to explain you today that what is the reason of that excitement. See, discovery of a new particle is something very common. We often discover it, as we will see. But why we were looking for this Higgs boson? And what happened, at one point of time, people started calling it God particle. And the origin of this name, God particle, is that when some scientists, out of disgust when this particle was not being discovered, said that where is this goddamn particle? And some publisher of a book, he removed the word damn from his statement and named it God particle. And that created some kind of impression among many that scientists are nowadays working with God. But that is not correct. So I don't want to say anything about God in this lecture, but what I'd like to tell you that at the end of the lecture, probably you will realize that this particle has nothing to do with God, but its property is really God-like. It is almost unbelievable particle. And I'll tell you the story. But you know, in every story, or even in many films you have seen, the hero of the film comes slightly later in the screen. So here also our main hero Higgs Boson will come slightly later, because I need to create the preamble, the background of why we are looking for this particular particle. So let me try to tell you the background, and then we'll realize the importance of finding this particle. Undoubtedly, in my opinion, this is one of the most crucial discovery in the last 100 years. So let me start this lecture. So science essentially starts with two very basic questions. If you observe that any branch of science basically addresses these two questions: what are the building blocks by which everything around us are made of? And how various things in nature they behave. Now see, if the behavior of various things in nature were very arbitrary, suppose now you release something, it goes down, after 5 minutes it goes up, after 10 minutes it moves in that direction, then you would have concluded that this behavior of this motion of this object is something very random. And you would conclude that nature is mad. Nature has a behavior of madness. But fortunately, nature is not. So every time you release it, it goes down. And whenever something is not random, something is not mad, always remember there is a reason that it is behaving in a certain way. And that reason, that why whenever you release something it goes down, these are called the laws of nature. Nature behaves in a certain way. But about the building blocks and structure, I would like to point out a very important thing to you. See, this structure is so diverse. Suppose this is a piece of soap and which is solid object in a glass, a solid object. Now this is, you can clearly see, liquid, and this is a gas. Now can you imagine how many solid objects you see around you? This is just billion. See, this computer pointer, this computer, this chair, this table, everything are solid objects. And if you count, they are actually, in fact, almost billion is in number. Similarly, there are so many liquids, so many gases. So nature, now I hope you agree with me, structurally very, very diverse, very beautiful. I mean, there are so many, different appearances. But interestingly, though they look so different, but as all of you look different, whoever, all the students, you are looking so different. I mean, each one can be distinguished from the other. But interestingly, if I go inside you, if I go take a more microscopic view, then what do I find? All of you, all of these chairs, all these tables, everything are made up of some molecules, which is much less in number. Much less in number. All of everything are made up of some molecules. And then you go inside the molecules, you will see all molecules are made up of some atoms which are even lesser in number, but by different combination. Something 2 hydrogen, 1 oxygen, maybe 1 hydrogen, 1 oxygen, maybe different number of atomic combination producing a molecule which has totally different character, different appearance. And then these atoms, which is much smaller in number, maybe 90 or 100, if you go inside the atom, even microscopically go inside, you will see all atoms are made of electrons, protons and neutrons. So if I say that though everything looks so diverse, different, but all of them are made of only three particles, electrons, protons and neutrons. Don't you think this is an amazing unification? That I am trying to unify the entire structure of nature by only three particles. These three particles, when the number of proton and electrons are something, this produces one atom, it is different, it produces another atom. It is different, produces another atom. So one proton or electron produces a hydrogen, then two produces a helium, and so different kind of atoms are produced, then they combine to different kind of molecules, then molecules combine to produce different kind of things which look so diverse. So apparently, nature, if you go inside, becomes very, very simple, only three particles. So if, now see, your job has become so simple. If you know the properties of only three particles, then you know the property of everything, because you can construct from microscopic thing to the macroscopic thing. So for this reason, we want to go inside an object, because the nature shows an unification inside. Everything is made up of much smaller number of things. So for this reason, as I said, I go from our body or to computer to glass to molecules, and then going to even smaller and going to even smaller. Now the question is, how can you go to smaller and smaller level? How can you do this? You can see, of course, this pointer, but can you see its molecule? You cannot, right? And if I ask you, can you see what atoms these molecules are composed of? You cannot see. And then no question about seeing an electrons and protons. So if I want to see them, what shall I have to do? What you will have to do is the following, in order to understand that. See, when you throw an ordinary light in your hand, you can see the hand. But can you see your bones? You cannot. Right? You cannot see your bones in my hand. But when I use an X-ray, you can see the bones, which is even microscopic. So, with light you can see a macroscopic structure, but not the microscopic, but with X-ray it can take you inside to show your bone. And similarly, if you take something, it will go inside your bone to show you the molecules. But light, X-ray, everything are electromagnetic waves. That means some electric and magnetic fields, they are oscillating, they are falling on my hand, getting reflected and coming to your eyes, you can see your hand. But the same electromagnetic wave in the form of X-ray falling on your hand, but taking the picture of your bones. So, there must be something different between light and X-ray, when one cannot go take a microscopic picture and other can. What is that property? Both are electromagnetic waves. The property that is responsible for this is the wavelength. You know, every wave which oscillates, this distance, the smallest distance between the two peaks is called the wavelength when something oscillates. Now, smaller the wavelength, more microstructure can be seen. You remember this. X-ray having a smaller wavelength can go to your bones. Light has a much bigger wavelength, cannot. So, in order to go inside, I need to take smaller and smaller wavelength. But smaller and smaller wavelength means wavelength and frequency are inversely related. Most of you probably know that as you decrease the wavelength, the frequency increases, because frequency and wavelength has a relation. Velocity is equal to frequency into wavelength. Since velocity is fixed, the frequency and wavelength, if you increase one, other is decreased. So if you decrease the wavelength, what happens? As I said, light, X-ray, gamma ray is even smaller wavelength. It can go inside your bone. In fact, it can be very damaging, because this can damage your cells. Smaller and smaller wavelength means higher and higher frequency, and higher frequency means higher and higher energy. So basically what I am trying to tell you, that if you want to see the unification of nature by going inside the molecules and atoms and maybe electrons and protons, you need to use the waves of smaller and smaller and smaller wavelength, that is higher and higher frequency, which means higher and higher energy. And for this reason, remember, the study of microstructure is called high energy physics, because we need very, very high energy beam to see that. Now the question is, you will say, the fine, then let us prepare very high energy waves and see what is happening inside that molecules and atoms and electrons, whatever. The problem is, I will tell you during the course of this talk that it is very difficult to produce high energy beams. It is not easy. I will tell you why. See, so we need to build up new machines which can generate very, very high energy to look into more and more microscopic structures. Is it clear up to this point? Any question? Building up these new machines, they are called, in the technical language, accelerators or colliders. These machines are called accelerators or colliders. They generate very high energy beam, very high energy waves. I'll tell you how high energy we have been able to develop so far. To create higher and higher energy wave is very, very difficult, as I say, and also require enormous funds. For example, the highest energy that you have attained in the Large Hadron Collider in Switzerland, Geneva, CERN, it